Introduction. Come on, son. Hurry up. We need to pack many more things.
Yeah, I'm coming. Please pack my 3 red and 2 white balls.
Okay, give them to me.
No, white one this side and red one in the middle.
Come on. Are you trying to arrange them in different orders?
Yeah, I was doing it, but I don't know how.
This is known to be permutation and combination. In this, we arrange the objects either in order or not.
Can you tell me more of this?
Yeah, sure. In this lesson, you will learn to arrange the objects in different manner. Objectives. At the end of this lesson, you will be able to count the number of objects using fundamental principle. Find the number of ways in which a task can be done. Place the objects in ordered and unordered arrangement. Fundamental principle of counting. Fundamental principle of counting. First, let's understand it with example. Ramesh wishes to go from Agra to Chennai by train and return from Chennai to Delhi by air. There are 3 different trains from Agra to Chennai and 2 different flights from Chennai to Agra. In how many ways can he perform the journey? Solution is, since he can choose any one of the 3 trains for going to Chennai, and for each such choice, he has 2 choices for returning to Agra. He can perform the journey in 3 into 2 ways, that is, 6 ways. The fundamental principle of counting stated below. If one operation can be performed independently in m different ways, and another operation can be performed independently in n different ways, then the number of ways in which both the operations can be performed in succession is m into n. If one operation can be performed independently in m1 different ways, and if a second operation can be performed in m2 different ways, and a third operation can be performed in m3 different ways, and so on, for any finite number of operations, then the total number of ways in which all the operations can be performed in the stated order is m1 into m2 into m3 and so on. Example. There are 6 candidates for 3 posts. In how many ways can the posts be filled? Solution. The first post can be filled up in 6 ways. The second post can be filled up in 5 ways, and then the third post can be filled up in 4 ways. By the principle of association, the 3 posts can be filled up in 6 into 5 into 4 is equal to 120 ways. Permutations. A permutation is an ordered arrangement of items. The concept showed below clear your concepts. There are 3 balls which are arranged in ordered arrangement. For example, consider the permutations of the letters A and B. Just think about how many different ways you can arrange A and B. The key to a permutation is that order matters. 1. AB. 2. BA. As you can see, the only difference between the 2 permutations is the order. In the first one, AB, A is first and B is last. In the second one, BA, all that we did was switch the order so that B goes first and A last. Permutations when all the objects are distinct. Theorem 1. The number of permutations of n different objects taken r at a time, where 0 is less than r is less than or equal to n and the objects do not repeat is n into n minus 1 into n minus 2 up to n minus r plus 1. which is denoted by NPR. Factorial notation. The factorial of a natural number n is the product of the positive integers less than or equal to n, 1 into 2 into 3 into 4 up to n minus 1 into n is equal to n factorial and 0 factorial is equal to 1. For example, 7 factorial is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1 is equal to 5040. 5 factorial is equal to 5 into 4 into 3 into 2 into 1 is equal to 120. Example: if n factorial by 2 factorial into n minus 2 factorial and n factorial by 4 factorial into n minus 4 factorial are in the ratio 2:1, find the value of n. Solution: n factorial by 2 factorial into n minus 2 factorial is to n factorial by 4 factorial into n minus 4 factorial is equal to 2:1. It implies n factorial by 2 factorial into n minus 2 factorial multiplied by 4 factorial into n minus 4 factorial by n factorial is equal to 2/1. 4 factorial into n minus 4 factorial by 2 factorial into n minus 2 factorial is equal to 2. 4 into 3 into 2 factorial by 2 factorial multiplied by n minus 4 factorial by n minus 2 into n minus 3 into n minus 4 factorial is equal to 2. 12 is equal to 2 into n minus 2 into n minus 3. 6 is equal to n square minus 5n plus 6. N square minus 5n is equal to 0. N into n minus 5 is equal to 0. N is equal to 0 or 5. When n is equal to 0, n minus 2 factorial and n minus 4 factorial are not defined. Rejecting n is equal to 0, we have n is equal to 5. Permutations. Formula for NPR. NPR is equal to n factorial by n minus r factorial. 0 is less than or equal to r is less than or equal to n. Theorem 2. The number of permutations of n different objects taken r at a time, where repetition is allowed, is n raised to power r. Permutations when all the objects are not distinct objects. Theorem 3. The number of permutations of n objects where p objects are of the same kind and rest are all different is equal to n factorial by p factorial. Theorem 4. The number of permutations of n objects where p1 objects are of one kind, p2 objects are of second kind, pk are of kth kind, and the rest, if any, are of different kind is n factorial divided by p1 factorial into p2 factorial up to pk factorial. Example: how many 3-digit numbers are there with no digit repeated? Solution: there are 10 digits, namely 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The hundreds place can be filled by any one of the 9 non-zero digits is equal to 9 ways. The tens place can be filled by any one of the 10 digits except the one that is in the hundreds place is equal to 9 ways. The units place can be filled by any one of the remaining 8 digits is equal to 8 ways. By the fundamental principle of counting, required number of 3-digit numbers is equal to 9 into 9 into 8 is equal to 648. How many signals can be given with 5 flags of different colors? Solution. Since any number of flags can be used to give a signal, hence there are following possibilities. 1. Number of ways when only one flag is used is equal to 5p1 is equal to 5. 2. Number of ways when any 2 flags are used is equal to 5p2 is equal to 20. 3. Number of ways when any 3 flags are used is equal to 5p3 is equal to 60. 4. Number of ways when any 4 flags are used is equal to 5p4 is equal to 120. 5. Number of ways when all 5 flags are used is equal to 5p5 is equal to 120. The total number of signals is equal to 5 plus 20 plus 60 plus 120 plus 120 is equal to 325. Find how many words can be formed out of the letters of the word Oriental so that vowels always occupy the odd places. Solution. The vowels in the word Oriental are O, I, E and A. Total number of letters in the word Oriental is equal to 8. Number of vowels is equal to 4. O, R, I, E, N, T, A, L. 1, 2, 3, 4, 5, 6, 7, 8. Vowels occupy odd places, that is 1, 3, 5 and 7. Number of odd places is equal to 4. 4 vowels can be arranged in 4 X-marked places is equal to 4p4 ways is equal to 4 factorial ways. Number of consonants is equal to 4. 4 consonants can be arranged in 4 places is equal to 4p4 ways is equal to 4 factorial ways. Required number of words is equal to 4 factorial into 4 factorial is equal to 24 into 24 is equal to 576. Combinations. A combination is an arrangement in which order does not matter. It defines how many ways you could choose a group from a larger group. Consider the example. A fruit salad is a combination of apples, grapes and bananas. Description. We don't care what order the fruits are in. They could also be bananas, grapes and apples, or grapes, apples and bananas. It is the same fruit salad. The formula for finding the number of combinations of n different objects taken r at a time is NCR is equal to n factorial by n minus r factorial into r factorial. Theorem 5. Mathematical relation between permutation and combination. NPR is equal to NCR into R factorial. 0 is less than, R is less than or equal to N. Important results. 1. If R is equal to N, NCN is equal to 1. 2. If R is equal to 0, NC0 is equal to 1. 3. NCN minus R is equal to NCR. It means selecting R objects is same as rejecting N minus R objects. 4. NCA is equal to NCB. It means A is equal to B or A is equal to N minus B. That is, N is equal to A plus B. Theorem 6. NCR plus NCR minus 1 is equal to N plus 1 CR. Example. If NCR is to NCR plus 1 is equal to 1 is to 2 and NCR plus 1 is to NCR plus 2 is equal to 2 is to 3. Determine the values of N and R. Solution. Given NCR is to NCR plus 1 is equal to 1 is to 2. N factorial by N minus R factorial into R factorial is to N factorial by N minus R minus 1 factorial into R plus 1 factorial is equal to 1 is to 2. Or N factorial by N minus R into N minus R minus 1 factorial into R factorial multiplied by N minus R minus 1 factorial into R plus 1 into R factorial by N factorial is equal to 1 by 2. Or R plus 1 by N minus 1 is equal to 1 by 2. Or N minus 3R minus 2 is equal to 0. Name it as 1. NCR plus 1 is to NCR plus 2 is equal to 2 is to 3. N factorial by N minus R minus 1 factorial into R plus 1 factorial is to N factorial by N minus R minus 2 factorial into R plus 2 factorial is equal to 2 is to 3. N factorial by N minus R minus 1 into N minus R minus 2 factorial, R plus 1 factorial multiplied by N minus R minus 2 factorial into R plus 2 into R plus 1 factorial by N factorial is equal to 2 by 3. R plus 2 by N minus R minus 1 is equal to 2 by 3. 2n minus 5r minus 8 is equal to 0. Name it as 2. Solving 1 and 2, we get n is equal to 14, r is equal to 4. Rajesh has 7 friends. In how many ways can he invite one or more of them to a party? Solution. Rajesh may invite one of them, 2 of them, all of them, and this can be done in 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, 7C7 ways. Total number of ways is equal to 7C1 plus 7C2 plus 7C3 plus 7C4 plus 7C5 plus 7C6 plus 7C7 is equal to 7 plus 21 plus 35 plus 21 plus 7 plus 1 is equal to 127. Did you know? Bhaskara 1114 to 1185 also known as Bhaskara II, and Bhaskaracharya, was an Indian mathematician and astronomer. Bhaskaracharya did important contribution to this subject. Summary. Let us summarize what we have learnt. The fundamental principle of counting stated as: if one operation can be performed independently in m1 different ways, and if a second operation can be performed in m2 different ways, and a third operation can be performed in m3 different ways, and so on for any finite number of operations, then the total number of ways in which all the operations can be performed in the stated order is m1 into m2 into m3 and so on. Factorial: 1 into 2 into 3 into 4 up to n minus 1 into m is equal to n factorial. The number of permutations of n different objects taken r at a time. npr is equal to n factorial by n minus r factorial. 0 is less than or equal to, r is less than or equal to m. Permutations when all the objects are not distinct objects. The number of permutations of n objects where p1 objects are of one kind, p2 objects are of second kind, pk are of the kth kind, and the rest, if any, are of different kind is n factorial divided by p1 factorial into p2 factorial up to pk factorial. The formula for finding the number of combinations of n different objects taken r at a time is ncr is equal to n factorial by n minus r factorial into r factorial. Relation between permutation and combination. npr is equal to ncr into r factorial. 0 is less than r is less than or equal to n. Important results. If r is equal to n, ncn is equal to 1. If r is equal to 0, nc0 is equal to 1. ncn minus r is equal to ncr. It means selecting r objects is same as rejecting n minus r objects. nca is equal to ncb. It means a is equal to b, or a is equal to n minus b. That is, n is equal to a plus b. ncr plus ncr minus 1 is equal to n plus 1cr.